Okay guys, last time we started looking at the abstract class. And before abstract class, we looked at what's called inheritance. So let's remind you what we have so far. So we do have what's called a superclass. We have superclass here. I assume there'll be a superclass. This superclass is going to inherit, for example, something for the superclass. What I assume this B and superclass A. So this subclass is going to inherit what? The attributes or the instance variable defined in the superclass plus the method there, right? That's what we have so far. Good. Of course, the public one. Subclass also can override the method to provide more specialized, implementation. For example, there's one method in A equal, for example, move. Or let's say toString. Or whatever. You inherit this one in the superclass. Now you have a choice. Either we use, the method that we inherit from the superclass. If you don't like their implementation, you can do your own implementation. We call this one override. Yes? Remember that? Override that piece. We have what? One method you extract, let's say, inherit from the high level. Now we're going to keep the same signature, the same structure, the same, let's say, API of the head of the method. The only difference is going to be the implementation. For example, if you have toString here, you inherit, for example, the superclass. Here, your toString that you define here is going to be different. You're going to have like different implementation, but you're going to use the same name. That's one thing. This is the override. Yeah. We do have something else here. We have what's called overloading. That means we have the same method. It's going to be have different versions of the same method within the same class. That's different story. Back to the override here. So it looks like here, during the execution time, the system needs to do what? You need to decide which toString is going to be executed. Yeah. So let me give you a quick example here. We have a class A. This class A has method to say, let's say use simple, notation here. I'm going to say be A1, A2. Or let's say move, walk. Something like this. Okay? Two methods. Class B is inherit whatever the functionality class A. Good? So we have two options, two choices. Either you override whatever method that you inherit with the superclass or leave them. Assume that I'm going to say I'm just override, the walk class. Okay? I create an object. Let's say B equal new B. Yeah, or let's say B1. Okay? This is an object with the class B. Okay? So when you say B1 dot, we say walk. Which method are you going to execute it? This method or this method? This one or this one? What do you think? Guys, are you here? Oh, thank you. Which one, the second one? From the B or from the A? It'll be easy here. Walk from the B class or from that we are defined from A class? Did you understand my question, guys? You have two methods, okay? You have move, for example, we have walk. Is implemented in the class A with the superclass. You inherit or create to say subclass with inherited or extended the superclass A. Within the class B, you just override, the walk method. You have your own implementation. For example, here's print A, here I'm going to be print B, for example. Then I create an object in class B. Then I said, this object is going to call the walk, this method. So the question, which one is going to be? Exactly. Thank you, Eric and Zachary. So it's going to be what from the class? Why? Because the system is going to start, this object belongs to what? This object from the class B. Does the class B has this method or not? Yes, execute it. If not, go to this one. The class B is extended to say from the class A, so definitely check the superclass. Maybe they have this method. So we check with the level that depends on the data type that we have, the object that we have. Check first Within this class, if you don't find the method that you're looking for, go to the dialog. Yeah. For example, we say here b1 dot, let's say, move. So in this case, b1 dot move, check here. Do you have move? No. I inherit this one from the superclass. Then I'm going to execute this. Clear. That's the meaning of it. So we're using this one. It looks like we have like, it looks like our program is going to determine the behavior to execute depends on the data type that you have. Kind of, yeah. Because right now, if you use, for example, A1 here, or let's say A1, and A1 is object from A, so it looks like I'm going to call this method that's stored in the A1, not from the B. Or assume that we have another class. Let's make it complicated. Another class. I know it's messy a little bit here. Assume that we have another class, which C is extend class A, and C is going to implement, for example, walk. So in order to create, so here you create an object, C1 equal new, let's say, 0. Then you say C1 dot walk. The system going to say, okay, C1 is like the walk, since this one override method, I'm going to execute the one that implemented in the superclass. So superclass, again, as you mentioned, can also override methods to provide more specialized implementation. What does that mean here? This implies that some methods call can be invoked. Different implementation depends on the object of the class type that's related to. Yeah. So here we say b1 move. You're gonna call b move, for example. Assume that I will say b1 dot walk. You're gonna call this b1 walk that you implement in b. C1 walk. That means you are going to implement a call, so the walk implementation in the C class. And that's it. Okay, so what's the polymorphism here? What's the meaning of polymorphism? Polymorphism, that means multi-faces, okay? So that's mean, or multi-shapes. So it refers to what? To determining, which program behavior to execute depending on the data types. In other words, it refers to the ability of the object to respond differently to the same method. Okay? So we're going to see this one more details how it looks like. So it looks like we have two different types of polymorphism. The first one, we call this one compile time polymorphism. Let me clear this one here because I want to write something here. So we call two different types of the polymorphism. That means the first one, we call this one compile time. That means here the compiler can determine which of the several identical, let's say, named methods to call based on the method argument. For example, if you have a multi-methods, or the base, for example, you have like, let's say, walk as integer, for example, A. Then you have, for example, walk integer A, for example, integer P. Then you have, for example, those belongs to specific class. I'm talking about the overloading methods. Both of them belong to class A. You create an object, you say A1 equal new from A. Yeah. Then you have, say, A1 dot, for example, walk 5. Yeah. So here, during the compile time, the compiler can tell exactly which method is going to be executed based on the parameter that we have. I can say A1 walks, okay, 5. That means we're going to call this method, this implementation. If you said 5, 10, that means maybe you're going to call the second one, and etc. here. Okay? There is another form of the what's called the polymorphism. We call this one the runtime polymorphism. That means I cannot tell exactly which method you're going to execute it until you run the code. That's the meaning here. Okay? More is going to be when you talk about the polymorphism. Keep this thought in your mind. It's not easy, by the way. Just if you understand the meaning of the polymorphism, so in this case, it's going to be easy for us. Okay? Back to the share file here. So let me show you here. Let's go with the formal definition of polymorphism, which is a very important property for the object-oriented programming. It is related to the what is called the inheritance. Remember, we said inheritance. We have subclass is a relation of an object of the superclass. We're gonna use this one in order to try to adopt, in order to come up with or to try to implement the polymorphism. So you can think about the polymorphism as is the ability of an entity to take several forms. And the simple example for you guys. Now you're sitting with me and you are mad, angry because you attended to today's class with me. After the class is gonna be done, you're gonna start happy, smiling, etc. So you're all the same person, the same entity, but you're gonna take different traits, different forms. Sometimes you are sad, sometimes you're happy, sometimes you are angry, and etc. Yeah, that's different. The other thing, for example, you can say you have a person in general. Person can act as a student, can act as, let's say, a family person, and etc. It's the same entity, but it's gonna have like different forms. It has take different forms, different shapes. Okay, we're gonna see this one. How can we gonna help us in order to, let's say, make our code more simple to read? Let me go to the definition here. The definition one. Okay. Maybe a second here. This is an important concept, okay, that we cover the inheritance, that an object of the subclass is also an object of the superclass. Since we have some method in a superclass is going to be inherited, yeah, it's going to be like inherited, it may be going to overwrite, they have a different implementation, lower level. So it looks like we have many subclass objects. It's going to do what? It's going to call the same method. Yeah, but the only difference is that the object you can use. So what I'm going to do here, I'm going to create an object from the subclass, and the data type of this object is going to be an object of the superclass. So I'm going to use the object of superclass in order to execute this method. And during the execution time or runtime, I can have like different behavior. So it looks like the object of the superclass is going to act as an object of one subclass, then let's say an object with the other subclass, and etc. So the polymorphism, the most important thing, is going to simplify the process of various objects in the same class hierarchy. Okay? Because we can use the same method call for any object in the hierarchy using the superclass reference. Let's see object reference. Let's see this one. In order to use, the polymorphism, this you have some requirement. Then I will give you an example here. You see how to use that. To use a polymorphism, you have many conditions must be satisfied. It must be true. The class are in the same. All the classes are going to be in the same hierarchy. For example, you have a saving account, checking account. Then you have like let's say a bank account, or you have a shape, rectangle, circle, etc. All of them, they're going to have the same hierarchy. Good, that's one thing. The second one, all subclass override the same method. So it looks like we have method. It's going to be, let's say, inherit from the superclass, and each subclass is going to have what? It's going to override this method. Okay? For example, we have the method, let's say, compute the area that we define in the superclass, yeah? And the shape. Then in the subclass, we have each shape, for example, the circle, rectangle, whatever, is going to do what? It's going to have its own implementation of what is called, the compute the area. All right? That's the meaning here. Good. So the same method, all of them are going to inherit, and they can have this override. That means they have its own implementation. Good. Override, that means, remember, I'm not going to change the structure, let's say the signature or the header of the method, just the content, just the implementation. Then, the last one, the superclass object reference is used in order to call the overridden method. That's confused sometimes, yeah. So it looks like, in this case, I do have shape. Let's say S equal whatever, create object. Then I'm going to say S, I'm going to say something S dot, let's say, compute area. Then during the, they say compute area, what's an object, okay? Then during the execution time, or the runtime, sorry, I can tell, for example, I'm going to call this method using, let's say, the circle class object. Then I'm going to call the same method using the rectangle object. Again, you have to have the following condition in order to use the polymorphism. The first one, the class in the same class, all of them are going to be in the same hierarchy. You have a shape, you have to say, you have circle, and you have to say rectangle. Okay, all of them are going to inherit, override, the same method. maybe more, but I'm trusting in one method going to be override by every single subclass. So I can use the object of the superclass in order to call this subclass. How can I do this one? I'm going to show you that. I'm going to go over this one later. This time is an example here. So I'm going to create like polymorphism example. Okay, this one is like run code or let's say client class. We'll try to let's say access or implement or run. I mean or test. I mean the hierarchy that we built last lecture. Remember, we have a shape. We have like circle, and we do have rectangle. All of them subclass from the shape superclass, and all of them is going to implement what is called the compute area. Clear? Okay. Generally speaking, when you work with the polymorphism, mainly we're going to associate the polymorphism with what is called the array list. We covered array lists before, yeah? So we are familiar what you mean by the array list. So here, I'm going to create an object, okay? This name is shape list, whatever name. This object from what? As an array list, and the object is going to have the superclass data type. Remember, you can create an array list of whatever object you want. It might be integer, it might be double, it might be string, it might be class. So I create this one, the shapes list, with an object as an array of the object of the shape class, the superclass. So here, when you say shape list 1 and 2 and 3 dot get 1, get 2, dot get 3, that means you mean that the object 1, the object 2, the object 3 from the shape class. I create this one is empty. Okay, there's nothing here. Do you have a problem with this one? No. Now we know that we have many objects in the subclass. Yeah, I create two objects. Just for example, one is called circle. This is normal, and you know that if you go back to the previous slides, you know the circle is gonna have like specific point, and we have the radius. Yeah, with the center and the radius. Then I'm going to add this object to the shapes list. What's the shapes list? Is the array list of the object of the shape class. Here, someone will say, how can we add object of the subclass to the object superclass? We know that the object of the subclass is an object of the superclass. We know that from the inheritance. All right? So I create this one or add this one into the object there. So we have the first entry in the shapes list, it's going to be an object in circle. Okay. Then I create another object rectangle, which is going to have, remember, we need 2 points in order to represent the rectangle. Then after that, after I create this object, I add this one to the shape list. So the shape list is going to have 2 entries. Shapes list. One object to the circle, and the other one object to the rectangle. Right? Do you have any problems so far? So good, hopefully. Do you have any question here? Please wake up. Good. Okay. So now the most important thing, I need to use this one using a polymorphism. By the way, you don't need to use a polymorphism. You can call, for example, without this one, you can create 2 objects and you call the circle dot, for example, compute area, and the rectangle to compute area. But we're going to do this one using polymorphism. So I'm going to use the object of the superclass in order to substitute the object of the subclass. And the system automatically can tell during the runtime, can tell this, oh, this is the object I need to run, for example, the compute area from the circle class. I want to run the compute area from the rectangle class, and etc. How can you do that? So here, so far, so good, we don't have problem. We have this result. Then, you know that you can iterate over every single object from the array list. We have enhanced loop. We covered this one in the class, yeah? So I can say, for every single element from the shape list, store this one in the shape object. Remember, we did this one using, let me run this one again. We can say for, as an example, let's say string s from whatever, or integer, or let's say a shape s from array list. Can you do this one? Yes. So it looks like you iterate over every single object within this list. Okay? So here, back to slides. I lost the slide. Okay? So here, for every single object, the first one, I know that means the first value for the shape, it's going to be stored in the shape here, lowercase. You can use any, notation or identifier. It's going to represent what here? So here, the first time, or when you run this code, which compute area and which class is going to be called? The one from the circle subclass or from the rectangle subclass? Here. Because right now you said shape.compute area. During the compile time, you cannot tell. During the runtime, yes, you can tell when you execute the code. So here, when you say shape.compute area, for the first element that I extract from the shapes list, I'm going to call which implementation or which override method that's stored or implemented in the circle subclass or in the shape subclass. No, you can, whatever the shape. What's the current value here? The first one, the circle, exactly. Because what happened here? You create shapes list. This is an array list. That means, remember, the array is an object. So this one, the first one is object of the circle. And the second one is the object of the rectangle. How I can tell that? Because the first one, I can add the circle here. Then another add, that means it's going to be add to the end of the array list. Yeah? Now here, when you say iterate over every single shape that's stored in the shape list, because for every single object here, put this one into the shape. Remember, the object of subclass is the object of superclass. So I can do this one. I can create shape object equal circuit object. Fine. Okay? Then, the first one is going to iterate the circle. So here, when you run this one, the first iterate over the first element in the shapes list, you're going to call the compute area that were stored in the circle. So it looks like here, you actually did, I called the following. You said, what's the object of the circle here? It's that we have a different color here. Use a different color. We have what? We have a circle here. So it looks like the first one, you're going to say circle.compute area. So that's what I'm talking about. This shape object, which is the object of superclass, is going to have many faces, different forms. Acting like circle object, that was the first time. Then when you iterate over the second element of the shapes list, now the shape is going to act as what? As a rectangle object. So it's going to call the rectangle object.compute area. Clear? I know it's not easy at the beginning, but if you understand this one, it's going to be easier for you in order to write your code. So that's the way that you're using polymorphism. Like I'm going to create an object of superclass. I use this object in order to call all the method or override method. And during the execution time, I need to write my code in a way that the system can distinguish, can tell which class, method I need to call. Exactly. Yeah, that's what I've said here. We said an example here, you can say integer or string, and it's over a single string. So it looks like in the shapes list what you said here, this iteration. Give me the first object. Store this one in the shape. So it looks like you said shape is equal the first object that's stored here. In this case, the circle that I just generated. Then the next iteration, iterate to the next element, take the second object and store this one, or let them reference to the shape. So the value of shape is going to be changed. Remember, we did this one using a string. You said for string, every value string that's stored in array list, or array that contains a string element, or integer, or whatever you want. Let me see this one. But when we call the computer area, we use the subclass. No. And what we did here, the goal here, you have what? We talk about the polymorphism, is the ability of an entity to take several forms. So it looks like you're going to do what? We do have one subclass, and we have some subclass, one superclass, and we do have a set of subclasses. All of them is going to override, let's say, one or more methods from the superclass. All right? Assume for simplicity, all of them is going to have only one method, it's going to be override. Clear? So we have a circle, we have a rectangle, which inherit, let's say, override, the method compute area from the superclass. I can write my code differently. I can use the objects of the superclass in order during the execution time, since I'm calling the override method using different, let's say, objects, I can rewrite my code. Instead, you create object every single subclass. Then here you can see explicitly. I'm gonna use the object. I'm gonna say circle, for example, dot compute area. Then later I'm gonna say rectangle dot compute area. Maybe you have more 5 subclasses. So all of them you have to tell the system that the name of the object call this method. I can do this one differently. I can use the superclass object in order to help me, in order to have only one call for the same method, yeah, the override method, and I put this one in the loop. And in the way that when you write my code, I can make sure that during the execution time or the runtime, the system can know exactly which override method you're gonna call from which subclass. That's what we did here. We create an object, you say an array. We call this one array list, shapes list. We store different objects of the subclass, create and store them one at a time. Then I iterate over this sublist. Every time you iterate for every single object that you retrieve from this array list, you can treat this one as object from subclass. Yeah. Then when you say all of the subclass is gonna call the same method. So I use only one object. I call this object from the superclass in order to have different. This object gonna have a different forms, different shapes. Yeah. And every time give me change from time to time. In this case, from it depends on the value that iterates over the subclass, or sorry, the array list. And every time it can tell me which subclass, the override method is going to be executed. Did I lost you? Did I confuse you? Good. And this is the way that we're going to do. That's the way how to use polymorphism. Simplify your code using, and you have a condition here. In order to do that, let's go back to the previous slide. We need to have a condition. Remember, we said that in order to use that, you have to do the following. What's slide number here? 26, 20, yeah. All the classes are in the same hierarchy. So we have a shape, we have this circle, we have a rectangle, all of them in the same hierarchy. So that's one thing, good. All subclass override the same method because I'm gonna call the same method, compute the area. Maybe more, but it depends what method now we need to compute. Okay, and all of them are gonna call this method. So this is a different way using polymorphism. So all subclass object reference is assigned to the superclass object reference. I create superclass object, and they use a subclass object and reference this one to the superclass object. How can I do this one? Since they have multiple, if you have one, that's fine. If you have more, that means you have to use array list. It's the easy way, the best way in order to do that. Because array list allow us in order to create, let's say, an array of objects. Yeah. Since the superclass object is an object, so I create an object from the superclass. Then create an object for every single subclass. Then add this one to the array list. Then the superclass object reference is used to call the overridden method. And that's exactly what we did. The superclass object going to use in order to call that. Okay? So let's have, that's what we did here, what we covered here. So here, the polymorphism example that you showed is going to satisfy or fulfill the condition that we covered. So come on. The class are the same hierarchy. Shape, circle, rectangle. Yes. When we say same hierarchy, that means we have superclass and subclass, all of them inherit from the same class. We don't have one class or subclass that belongs to different hierarchy. So for example, if you have a bank account doesn't belong to the hierarchy, so I cannot use it here. It's a polymorphism. As one unit, we can use with the other, you create an object from the bank account in order to take care of the checking account and the saving account. All the subclass override the same method. All of them is gonna override the compute area. Okay? All subclass object reference is assigned to the superclass object reference. Yeah? That's what we have here. One asked me to say, what? This is abstract class. Yes, abstract class. Remember, abstract class, we said you can declare an object, but you cannot instantiate using the same superclass, yeah? If you have abstract class. But we instantiate using different objects for that superclass, which they are concrete classes. Okay? The superclass object reference is used to call the overridden method, which is that what we did here. We said the shape.compute area, or the shape that we create that help us in order to perform the reference. Actually, this one, there is no, it's not method, it's, an object here. Okay, that's all about the the polymorphism. So what I'm going to do here, let me go to show you an example, a short example using Eclipse, and you see how it works. Then after that, we're going to talk about the interface with different ways, or different implementations, similar to the abstract method, but it's different a little bit. Okay. I need to show the Eclipse, and they want to. It's chapter 10. I will upload the slide, the codes after today's class. So I guess we have all the method here, polymorphism example here. So that's what we did here. The same code that I just showed to you here. Okay? The only thing what I'm going to do here right now, just run the code here and see what's going to do here. You see that the first one, let me what I write here. Oh yeah, add this one. So what I added, I add the shape.get class. I just show you that to prove to you that this object every time is going to be changed, it has different form. So this time it's going to take the value of the object. You can't tell what the exact class stored there. So you see the first one is going to say, give you this class that's stored in this chapter, and the name of the class is circle, the first value. Then the area is going to be shape.compute area, so you know that the compute area of the circle. Okay? Then the second one, the second value of the shape, or after the next iteration, I say this one, give me the class, just this one, get the class just for us to make sure that convince you that this let's say the polymorphism is going to take, several forms. It might be, the beginning is going to be, it can take, for example, the circle, and after that, the rectangle. If we have another superclass, add the array list so we can display the value here, or show the value here. Okay. One interesting thing we talk about right now, we call this one the interface, which is similar to the abstract class, but it's different. It's more advanced, they have more features, and we have more control here. So what's the interface here? Java provided what is called the interface, okay, which is another mechanism for the programming in order to state that the class adheres to the rules defined by the interface. The same thing we did with the abstract class. Why we need abstract class? In order just to tell the user or anyone who try to expand, or let's say extend or implement, or let's say extend this superclass, this is the following function or method that you need to implement. This is the structure. This is what is called, the header, or the signature, or the definition of each function, but you just to come up with your own implementation when you implement this superclass. All right? They have another way in order to do the same task using the interface. Interfaces add more features than the abstract class. The class can inherit directly from only one class. This is the problem with the abstract class. That means if you have, for example, a class A superclass, you need to extend or inherit a new class from the superclass. You can only extend only one superclass, no more. For the interface, different. For example, I show you different interfaces. You can, implement whatever interface that you're going to do, either from one interface, two interfaces, three interfaces, four interfaces. You can implement many functionality that you want. You see the difference? So it looks like the interface abstract class plus more, add more features. Okay? So again, in order to allow class to inherit, behavior from, let's say, multiple class, or multiple source, I'm gonna use the interface here. Okay. Clear? Okay. Good. So an interface, it has many members. It looks like special structure. It's not a class, it's interface. So in this case, we have like a specific features here. The first one, interface can have the following, the members inside the interface. Looks like the structure of the interface. It can have classes, okay? It can have, let's say, a constant. Only you can define instance variable as a constant. You can define a class. You can define what's called public abstract methods. You can define what is called public default methods. You can define what's called public static method. You can define what's called private methods or other interface. So we're going to go over one at a time. The first one, a class, we know that you can create a class within the interface. Good. You can create an, let's say, when you say create an, let's say, variable or instance variable can be an object of the class. Okay. You can create a constant. Instance variable must be a constant, nothing else. Okay. That means if you define an instance variable is not constant, it's not allowed in the interface. Only constant. Good. We have what's called abstract method. Generally speaking, the interface is going to do what? It's going to be the way that make sure that every single subclass must adhere to the structure, or the rules, or the set of, or this say, those are the set of the method that you expect from you to implement. Okay? The structure, etc. Yeah, we see this means final. I'm gonna go over this one more details about the concept. But yeah, static final. Okay? You can define the abstract method. Okay, that means you have a set of method. That means anyone implement. You're gonna see is not extend is implement. That means show you this method. You have to implement all of them. In this case, we call this one abstract method. You can have what is called default methods. That means by default, anyone implement this interface by default is going to inherit all the public method or all the public default methods. I'm going to cover this one later and show you what do you mean by the default method. Public static method, you can define a method as a static, and you can specify either it's going to be public or it's going to be private. What do you mean the private method? Generally speaking, why do you need a private method, by the way, in any class or interface? We use the private method, for example, if we have like, I'm going to implement many methods within my class in general. Okay? I notice that there's a portion of the code that's going to be repeated in many methods. So it's better to put this one in private method. So I'm going to make my codes easy to read and less number of codes. And I'm not going to repeat the chunk of the codes yet. I notice that every single method is going to be repeated or acts the same set of codes. Then I put this one in private method. I put this one in private because this one only going to be accessible or used within from the method that defined within the class. You see that? Then you might have other interface. Let's go one at a time here. First, how can you define interface? It looks like, how can we create an extra, let's say, abstract class? How can we create a class? If you only have like a syntax, show you in order to show you the exact steps that you need to follow. Okay, so in order to define an interface, I'm going to use this following syntax. You're going to say access modifier, public. Generally speaking, the interface is going to be public. Okay, the name is interface. It's not a class. Then here, the name of the interface. I'm going to use the same notation that we follow in the class. The first letter is going to be uppercase, and the first letter for every second, inner word, let's say, word is going to be uppercase. Okay? Then here you have the body of the interface. That's the way how to create it. Generally speaking, all the interfaces are abstract. Okay? They cannot be instantiated. You can just declare, but you cannot instantiate an object. You can say interface 1. This I declare an object as what? Interface 1, but I cannot say new, equal new or something. No. Okay? But of course, a new one, I say you cannot, because there is no, let's say, default constructor. There is no constructor associated with interface. Similar, there is no default constructor associated with what's called the abstract class. Okay? So the abstract keyword, that means can be omitted. I'm not going to add this one. Generally speaking, you can see public, abstract, interface, etc. But since it's going to be by default, its interface is abstract, so I'm not going to add that. Okay? You can add this word, but it's not important. You can omit this one. Similar to the class, so definitely when you create an interface, you have to store this one in the file, .java. But the name is going to be the name of the interface. So it looks like you're creating a class, the same way they create an interface. Remember, when you work with the interface and you are going to upload your code, you have to upload this file that contains the interface structure or definition. So, generally speaking, when you build the class, here, you have the class, for example, 1.java. Yeah. After creating, you're gonna find the file gonna be stored here. If you create an interface, the interface is gonna be interface name.java stored there. So you need to make sure that when you upload your code to during the coding assignment or whatever, you need to make sure that even the interface file must be uploaded. Yeah. Otherwise, your code is gonna be miss something. Okay. So that's the structure, the simple thing here. Generally speaking, in the interface, it's gonna have what? It's gonna declare only the methods, okay? But these methods gonna be what? There is no implementation of this method. That's why we said, mainly, this is the main thing, okay? Declare method, but typically not provide an implementation. That's the old days of the interface. Things change from the Java 9 and 8. Okay, they add more features. In my early days, when you work with the interface, we cannot define a method inside the interface. Then after that, for every single version of the Java, they add more features. That means it's a good thing that if you hear that there is a new version, published in the Java, so you need just to take a look to see what's the difference. Maybe they definitely have more new features. It's gonna enhance the way that you write your code. So it used to be there is only the interface only declare a method, but there is no implementation. Starting with Java 8, interfaces are allowed to implement instance non-static methods. Okay, we'll see how can we improve. That's why we have default methods, we have like public static methods, and etc. Okay. What kind of field can be stored in the interface? Only constant. Instance variable, only constant. So interface fields are public, static, final. That's why I said, it's constant, okay? You didn't need to specify that because by default, if you create an instance variable, the system knows that since it's like, you define this one as interface, so there's no need to more detail say, oh, this is an integer, this is, the constant instance variable. It's constant, public, static, final. There's no need to do that. I know that by default. It doesn't hurt if you write that. Okay? Of course, if you define any instance variable, since it's a constant, I need to assign specific value to this variable. Yeah? Because there is no default constructor that's going to take care of this one. There's no constructor here. I cannot instantiate any object. That means if you define any instance variable, you define this one or declare this one as instance variable in the interface, you have to assign the value or give value to this object, this instance variable. Okay, so this is this is how you define the fields or the instance variable. The methods, we have many methods. At the early days, there is no method. Then things change with the time. We can define a method. You can remember you can define a method, and also you can specify the implementation of the methods here too. Not all of that. So we have different methods we're going to perform. Generally speaking, this is the main purpose why you need an interface. I need to define what's called abstract methods. Okay? So by this way, when I say anyone who try to implement, this interface, those are the set of methods that you need to implement them. You don't need, you cannot change, what's called the signature or the header of the method. If the method, for example, public integer return integer value, and the name of the method has specific name, and this method has the same, for example, the same arguments, this means you have to do the exact thing. The only difference, you are going to override them. You are going to implement or provide the implementation of this method. Okay, this is the abstract one. By doing so, we can make sure that everyone inherit or this interface is going to adhere to the rules of the set of the method that I can. Of course, you can add more, but those are the most important methods. For example, we can create a game, and the main interface of the game that we can move, jump, yell, shoot, kick, whatever. This is the name of the method with some attributes. But I'm not gonna assign any, let's say, there's no implementation, it's gonna be abstract. Anyone is going to create an object, or implement this interface is going to implement those set of methods that I described above or before. Private method. We talk about this one when it's going to be private method, and generally speaking, going to help us in order to reduce the repetition code within the same class. If you have, as I mentioned, subset of code, you notice that it's going to be repeated among many methods. So put it better so to put this one in the private method, so you cannot access one from outside, and it's going to be called by the other method. So it's going to be have like reduce the repetition part or repetition of the code in our class. Public or private static method here. You can define public or private. Exactly, public and or private, because both of them you can perform this static method. Okay. So this means you can have like some methods within the interface do some with implementation. That's the meaning here. Okay. You can call them public. You can call them private. Either is fine. Okay. Default method was one interesting thing here. I'm gonna cover this one later. So how can we, after I create an interface, I define and put some abstract methods and etc. Then now the change looks like we have defined superclass. Now we have a superclass going to inherit, or say, in this case, is going to implement the interface. This is a structure. Remember, public class, whatever, the name of the class, the name of the class. Here you have many choices. Either this class is gonna extend superclass. If it's gonna extend superclass, it's gonna extend only one superclass, which was the one that we did here. Implements. If you said implements, this means we know that now you need to implement an interface. You can implement 0 interface, 1 interface, 2 interfaces, 3 interfaces, 5 interfaces, whatever. Sometimes you're gonna find in my activity with this subclass, I need to take interface 1, the functionality that defined in the interface 1 and interface 2. Implement them in the same class. You can do that. It's fine. Using, inheritance, you can only extend, you can only inherit from one superclass. Here, it looks like you can inherit from more than one superclass, because here you can use interface 1, interface 2, 3, and each of them is going to define a set of the attributes that you want to execute, and you're going to be implemented. Clear, guys? So this is a structure how to define that. Okay. So let's have a simple example here, okay? So here I'm gonna create an interface. Of course, there is a public here, interface, the name of the interface, curly brace here, and here we have only this interface is gonna have like one method. I call this method default method, okay? I think I have implemented, reason later why you use this one. Let me show you the reason why you need a default method, then I'm gonna go back to the example, okay? So what's the default method here? Oh, I missed it. Okay, let me go back to my slides. Which slide they used to be? I'm not gonna jump. Okay. The default method, we call this one is a public method and has a method body and also the signature and implementation. Why you need this one? It's used, solve the problem that how can we add a new method to an existing interface. Let me go back to my said early days. You're lucky, guys, if you have more features. If we work with the interface long time, interface only allow you in order to define what's called abstract methods. Only. Yeah, that means you have to implement. Then after that, they said, okay, we allow you to, maybe you can use some method to implement some methods here. Okay. The problem here, you have one interface. You implement this interface. Now we have method A, B, C. Assume that we have 3 methods. Now we have a class 1, and you have a class 2, and maybe you have a class N. All of them, each of them implement, this interface. This implementation, by the way, is going to be dashed line. We're going to see this one in the UML. Okay? Now we decide we wanted to add more functionality or more method to this interface. What if I want to add class or method CD? So we don't have a problem here. If I want to do this one, yeah, the subclass they implement this interface, now it's going to have an error message. It's not going to be compiled. Why? Because if you try to implement an interface, you have to implement all the abstract methods. If you add a new abstract method after implement, that means that's what we need to do here. Access every single class, and we execute this one, and or for every single class we need to implement the class, what's called the method T, which time consuming. Yeah, this is a problem. Then what they said we can add more feature to the what's called the interface. You can define this method as default method. If you did this one default method by default, that means every single class that implements this interface is going to inherit the default method. So that solves the problem. So that means I'm going to put my implementation here, add a new method. I define this one as default. So class 1, class 2, whatever the class that you have, all of them is going to be run normally. And by default, all of them is going to have access or going to inherit the default method. That's why do we have, or we need to have the default method. Clear? So let's have a quick example here. Assume that we have, this is, what you call interface, this table. Okay, this interface have like default method we call say, and for example, it's gonna say something. And the say something, we define a private method within the interface. So this is my interface. Okay, that's how it looks like here. This interface will have a default method, and it's gonna have what's called private method. Private method, that means only called within the interface. Right? Good. Now, I create another, let's say, private interface class which is going to implement the sayable method. If you implement this one here, you don't have any abstract method you need to implement. Yeah, so I'm fine. So what I'm going to do here, I create an object of this method. Yeah, just I want to show you that by default, when you do that, this class is going to inherit all the default method that we define in the interface. It's going to be accessible. Okay, I create an object of this subclass, or this class inherits the interface. Then I say s.says. When I do this one, someone say from where the say came from. We inherit this one from the interface because it's default class. Method. So I call say. Say is gonna call this method. This method is gonna call the private method that is stored there, and the result is gonna be hello. I'm a private method. This result is gonna be displayed here. This one you cannot use the default method unless that you have the Java 9 or higher. If you have a Java 8 and try to run this code, the system is gonna say we have a problem with the interface because we don't know that you're allowed to use this one. This is not allowed at that time. But starting Java 9, you can use this one. Okay? So this is the method. This is how can you use the what's called the default method in the interface. Okay. So now let's have an example. I'm going to create an interface, and they call this interface my interface, and this one is going to have like, let's say, instance variable, must be static, must be what's called, let's say, has value, constant. Do you need to say public static final? There is no need. The system by default can understand that. Okay, because this is the only instance variable that you allow to create, allow to have during the interface. By default, it's going to be constant. I have to assign the value, so I call this one, for example, the name is hello, and I assign the value hello. Okay, good. Then I create what? Abstract method. How can you tell this abstract? Because I have the name of the method and end up with the semicolon. There is no curly brace, there is no implementation, so I know that for sure this is abstract method. That means if you have any class, remember, class try to implement. This interface must implement every single abstract method that we have here. Okay? Must we say implement. I saw many students that have a problem when you work with interface, the subclass that inherit or implement the interface, they use extend. It's not. Extend only to the superclass. Interface, you have to say or use what is called implement. Okay? Good. So when you have many ways in order to access, in order to implement this interface or create an object of this interface. I'm going to show you an example here. So here, I'm going to implement this interface, then I'll get back to the previous slide. The name of the class that implements this interface, this name, whatever name you have, then implements the name of the interface that we just showed you in the previous slide. Then here, remember, if you try to implement interface, you have to implement every single abstract class. This one I can't change. the header, because this is going to be defined in the interface. The only thing I need to do here, whatever activity you want to perform. Here just to say, please print the value. And remember, notice what I've said here. I've said, remember, my instance is say interface, sorry, dot hello. Someone is say, this, what's going on? You call the whatever the use the interface name dot static variable. Can do this one? Yes. You can access the variable or the constant instance variable that you define in interface in many ways. Either create an object from this interface, okay? Then you can create an object and you create and use initialize this one as, let's say, an instance from the class that you use to implement the interface. I'm going to show you the example. Or you can use the name of interface dot and let you access to what's called the instance variable defined there. So that's what we did. I will show you example of the slide. Okay, I mean using the Eclipse. So here when you perform this one, I'm just printing. I use this method. I'm going to access the hello, which we define this one as the constant instance variable in the interface, and the value is going to be equal to hello. I know confused. We call hello hello. So we have many ways in order to access. Okay. In order to run my code, I need to have a client. Yeah. Remember, we have looks like one class and the class superclass. We have a subclass gonna extend superclass. Then after that, we need a client in order to access the subclass. In order to test my code. The same thing that we're gonna do here. We have an interface. We define interface. We implement a class. We define a class or create a class that is going to implement this interface. Then after that, we are going to create a client class in order to access the class that you use in order to implement the interface. So just this is, I'm going to use the same name of the class. I add just client or whatever name. And with this one, within the main method, you see that different ways in order to access the class used in order to perform or implement the interface. The simple thing here, you can declare a variable from what is called the interface. It looks like I'm not going to say polymorphism is similar. I can't remember the object of subclass is the object of superclass. Same thing. So here you're going to say the interface that I have can declare an object, but this object can be initialized as what? As they say, an object of the subclass or instance of subclass. Okay, so in other words here, you cannot say the interface, my interface equal to new my interface here, because I cannot do that. I cannot initialize this, but I can perform differently. It looks like here we have example here, quick here. Give me a second. So here in this case, what? You have a reference variable that we use here, which in this case is going to be interface what? Of, let's say, my interface type. Yeah, this one reference. Then here you can have what? This is the actual object that you're going to create. This actual object is going to be an instance for the subclass that you use in order to implement the interface. So in this case, yes, you can do that. Do you follow me? Good. So then after that, you can use this object now of my interface in order to say hello. I call the say hello to the class, then it's going to execute. Okay? Again, you cannot create instance of the Java interface by itself. You cannot say my interface equal new my interface. Okay? Let's go to having a quick example using, take a look at the Eclipse. Just I want to make sure that I have the names, my interface, implement client, make sure that I have the same or access the same, let's say the Java class. Let's take a look. My interface, I think my interface, yeah, this one. Let's change what says hello to hi CS4, let's say 201, just to change the code. Okay, this is the value. Okay, this is my interface. Then that's my interface implementation. Let me close everything here. I need to close all. Save here. So take a look. This is my interface. Okay. Then here my interface implementation. The one that's gonna implement the interface. Okay. What we said we create. I remember this interface has one abstract class. I want to implement this abstract class. Okay. How can you tell, again, this abstract class, there is no implementation, and there's semicolon after the, declaring, the classes, the method itself. That's why it's abstract method in this case. Then you need to implement this. Okay? Okay, so let me have something here. Can I say abstract? Okay, sorry. You can do that, but you don't need to do that because the system is going to understand by default it's abstract. Okay, since there is no implementation, okay? It doesn't hurt if you add abstract, it's fine. Hey, I implement that, good. Now I need just to play around with using the interface here. So what we did here, I take this interface name, I create a reference for the interface, declare. But the actual object is going to be what? Is my interface implementation with the class that you use in order to implement the interface. You can create an object, okay, and specify this object on the right side as a new class here on the keyword. This one is going to be an instance of any class used in order to implement the interface. It's going to be fine. If you use another class that you doesn't use in order to implement the interface, the system is going to say, I hate you, don't do it. It's going to give you an error message. Okay? This is one way. I call the same, the method that we have here. And let me see when you say my interface here. Let's click here. If you click here, you're going to see, unfortunately, you cannot see that. You can see all the methods going to be inside the method. It's going to be inherent in the interface itself. Remember, it looks like you have a class. And you're going to see, if you do that, you're going to see the hello is available. You see the instance variable that we define as a constant is available. I can't see it here. You can't because apparently I don't know why the backboard, the alter cannot allow me to record this one, but you're going to see this one in the recording. If you just click dot here, you're going to see what, go down until you see the hello, you're going to see you can't see access the element itself by itself. Okay? So accessible here. Let me do this one here. Let me say, I will put this one in parenthesis statement. Or you can create an instance variable for this class that use an order to implement interface, then call this. Either is fine. Either is going to allow me in order to access the interface. Okay? How about I say system.out.println. Okay? And here I'm going to say, my keyboard has let me down today. And here, let's see. Yeah, let me have the name of the interface that we have here, just to show you that I can access the instance variable, this constant that we define as constant. And here dot, let's say, you see, you're gonna see hello, and you're gonna have hello. You can see, yeah, and semicolon, and see what the result looks like. So you see that I can access what they have instance variable that I define here. When you run your code. And this is high. Okay, this is gonna see. Just to distinguish which one you're gonna call this. Okay. Question. So we managed to create a small, simple interface. Of course, we can make it complicated, but at least now we know the polymorphism, how it works. We managed to create an interface. Yeah, and we managed to have creating a class that's going to implement this interface. We managed to figure out a way how can we access the interface or the elements that store the method that store the interface, etc. Okay. So let me see what we're going to do here, because we have a lot of stuff to perform, but I need to make sure that we understand the material in order to jump to the next part. But since we're doing great, then let's continue. Okay. We cover this. This is the slide. Okay. And we know how to create or access interface. Good. Let's have another example here. Now assume that we have some class, okay, whose instance allow us in order to access their fields. So I'm gonna create like generic field accessor as interface. And for every single class, I'm going to implement this method within this interface. And this one is going to allow me to access all the instance variables that are stored in this class without, using the same or generic value. So again, this interface, or this generic field accessor here, which an interface is going to specify that what method that you're going to use in order to allow me to access, let's say, all the fields that's stored in any class. So again, this is the structure. This is the rules. This is the method, how it looks like. Method. Then every single class must implement this interface in order to achieve this code that you're looking for. This is just an example, weird example maybe. Yeah. So any class may implement this functionality independent of what superclass is derived from. So this means we're gonna see. Let me go to the next slide. Give you an example here. We can, for example, create a class, and this class maybe it's gonna be extend subclass, whatever. Then it's going to implement, let's say, a specific interface. This interface is gonna just declare or show them there is a method. Is this method gonna get field value? If you give me any field or any string, the system is gonna, based on implementation, it depends. It's gonna check whether the fields exist, or this is gonna be an instance variable stored in this class. If there, is gonna return that associated value. Okay, let's do this one. So I create an interface. I call this one generic, field accessor. Okay, and this one is gonna give me get to any field. Okay, and this is the structure. I don't know this one interesting thing. I don't know the return data types here, because this one is gonna be any class, yeah, because it's gonna be generic method. So in this case, I can use an object as a return value. So when someone say, what is the object? You know that this is, the main class or the first class that we can use in the Java. Every single class is gonna be inherit from the object class. This is the parent, yeah, the parent class for every single class in the Java. Okay, so create an the return value is gonna be an object, whatever the field that you have. This is the name of the method, and here the user is gonna give you a specific string, and based on the string you can tell whether the fields exist in the whatever class or not. If it exists, you're gonna return the value. Okay, let's assume that we have two classes. The first one is called person, the second one is called car, okay? For the person, it's gonna contain the following information. Both of them are gonna implement, the interface just to define. That means we have an abstract class, each of them gonna have its own implementation. Okay, so we have a private, assume that we have a name to instance variable, is normal class, yeah? Both of them have two instance variables, they are private. They cannot access them directly until you define getter and setter methods. Okay, the first one name, the second one is age. This is the default, the overloaded constructor of this class. Okay, then here that's what I'm interested. Of course, we have a getter and setter. I'm not interested. I'm just focused on this part. Now we have what is called the abstract method that I want to implement. That I got this one from or inherit this one from the. What's it called the interface, because it said implement interface here. Okay, if the field's name, whatever the value that I got here, dot equals name, because if this one is equal name, that means the user wants to retrieve the name value or the instance variable name. Yeah. Why I use dot equals here? Why did you use equal to? While you think about the answer, I'm gonna drink water. Question: why I'm using dot equals here? No, why I'm using equals? In order to compare string data types, you cannot use equal to. You have to use a method, yeah? Can I say, for example, string 1 is equal to string 2? No. Exactly. Compare to a string object, you compare them whether they are equal or not, you have to use dot equals. You did this one in one of the previous labs, yeah? We covered this one before. Compare and match, and in order to see the equality between two string objects, you have to use what is called dot equal methods. Otherwise, you cannot compare two string values. Okay, so just compare the string value. This one string with another string is the equal names, then it means return the name. Else, if it's, for example, equal age, that means return age. I can say else return, for example, null or return an error or whatever. Yeah, because it does not exist. We assume that we return null. as an object here. So that means the object is going to be has empty. Okay, this one thing. For the car, let me go over this one quick here. The car is going to have like a few instance variables. It's going to be brand, model, and year. And here, this is the overload constructor of this class. And here, of course, you can do getter and setter, but we try to use what's called the get field of the generic method that you inherit from the interface in order to just substitute using getter methods. So the user gonna give me whatever field you're gonna retrieve. If the field is gonna be brand, that means return brand. Of course, you can use else if. Okay, I'm not looking for the best way in order to implement that. If else statement is gonna be best, yeah. Or case statement gonna be switch gonna be nice here too. We have different ways. Okay, if else whatever you want. So you check this one brand or this model. If this year, otherwise you're gonna return no. You see that we have many return value, but one of them is going to be executed. Okay? Now, let's have what is called, a client class. We're going to just try to assimilate or try to check whether our implementation is correct or not. I'm going to create two, let's say, objects. One for the person, the second one for the car. And you can use here the name of the, what you call the interface. We said it's fine. Okay? Then here, you can say, I'm gonna say system out print the value from my dot format. This is the way to how this is by the way different way in order to perform print statement. You can use a string dot format and this use a %s as a placeholder in order to substitute the value with whatever and string value in this place, and %d that means substitute the integer value as used as a placeholder when during the execution time. Take the second argument here and substitute the %d with the value of the second argument. Okay, this is a way to how to perform print statement. So the first one, I'm gonna say x.get field value for the name, and this one get me the value of the age. Looks like you said that dot get age name. Give me the exact value, and you perform this one the same for the y. When you run this code, this is the result looks like something like this. Let's go over the an example through the Eclipse and see how it works. So take a look, let's close everything here, just at least to see the class here. Let's take a look at the generic first. Okay, this is what we have. Let's have only one, abstract class. Again, you can add abstract if you want. The system by default knows this is abstract, so there's no need. The same thing, there's no need to write public, because if you don't write the action modifier, the system can know that this is public by default. Okay. So then let me check, the person and the car to see how we implement them. So this is a person, this is whatever the instance variable. This is the overload constructor. And here that our implementation for the method that we inherit from the interface. Here for the car, define the instance variable that we have here. And you're gonna try to access them using the get value method. Okay, this is the same thing that I show you in the slide, and just have the client to create two objects, and those objects are gonna have this the following values here. Let's be here, we try to have all of them here. Yeah, this is the result, all of them. Okay, so when you run my code, and you see that the person X has say name Peter and age 59. The car Y has brand Porsche, oh my gosh, and model 311. It costs millions of dollars, I guess, in order to get this car. Anyway, any question, guys? We still need to work with the interface more. You are going to cover the next lab or the coming lab, you are going to spend time in order to work with interface. If you understand today's lecture and the lecture before that, the inheritance, abstract class, polymorphism, and the interface, then you don't have any problem with the class. Okay? Any question? Okay, that's all, guys. See you on Wednesday.